Today I'll be explaining synovial joints as a whole, along with the functions and classifications of synovial joints. A synovial joint is created when two bones that articulate together are separated by a joint cavity containing fluid. Synovial joints are freely movable joints, which makes them a diathrosis. The five distinguishing features of synovial joints include articular cartilage, joint cavity, articular capsule, synovial fluid, and reinforcing ligaments. Articular cartilage is located on both opposing surfaces of the bones in a synovial joint. Articular cartilage serves to take on compression impact and to assure that the spongy bone does not become damaged. The joint cavity is space between the bones that contains synovial fluid. The articular capsule encloses the joint cavity and is like the periosteum in the way that they both surround the diathrosis, and it brings together two articulating bones. The articular capsule is composed of two layers, the inner and external layers. The inner layer of the articular capsule is called the synovial membrane. It is made of loose connective tissue, and it covers any internal joint surfaces besides hyaline cartilage. The external layer of the articular capsule is considered the fibrous capsule and is made out of dense irregular connective tissue that strengthens joints in order to make sure bones are not pulled apart. The fourth classification of a synovial joint is synovial fluid. It is located within the joint capsule, and it serves many purposes, such as reducing friction by creating a slippery surface and making sure that through phagocytic cells, microbes and cellular debris have been ridden from the cell. Synovial fluid filters from the blood, and it is part of something called weeping lubrication, which is when synovial fluid is released from cartilage when it is compressed, but it is absorbed back into the cartilage when the joint has been relieved. The last distinguishing feature of a synovial joint is reinforcing ligaments, which are just thicker and more dense areas of the fibrous capsule. A common example of a synovial joint would be hips and knees, but there are several subcategories of synovial joints, which are gliding joints or plane joints, a hinge joint, a pivot joint, a condylite joint, a saddle joint, and a ball and socket joint. A hinge joint is when the surface of one bone articulates with the concave of another bone, such as the elbow. A pivot joint is when the cylindrical surface of one bone articulates with the ring of a bone and ligament, such as the axis and atlas articulating when one shakes their head back and forth in a no motion. A ball and socket joint is when the ball-shaped head of one bone articulates with the cup-shaped cavity of another. The hip and shoulder are both examples of a ball and socket joint. A condyloid joint is an oval-shaped condyle of one bone articulating with elliptical capital of another, such as metacarpals and phalanges. A gliding joint consists of two articulating surfaces that are generally flat and slide or twist together. An example of a gliding joint is the wrist and ankle bones. A saddle joint is a concave surface articulating in one direction and convex with one another back and forth. An example of a saddle joint is the thumb between the first metacarpal and trapezium. Synovial joints as a whole are the most common and most movable type of joints, which means they make up the range of motion. The range of motion in a synovial joint is based off of the strength of ligaments, and it differs between what type of actions each joint is using based on the activity of the individual. The origin of a joint is the attachment of a skeletal muscle at a less movable bone. The insertion of a joint is attachment of a skeletal muscle to a movable bone. Joints are examples of levers, and there are three classes of levers, being first, second, and third class levers. The components of any type of lever are the load or resistance, the fulcrum, and the applied force or effort. The load is the object being moved, the fulcrum is what the lever rotates around, and the applied force is what is being pushed or pulled to activate the lever. A first-class lever is when the load is on one side with the applied force on the exact opposite and the fulcrum in the middle. An example of a first-class lever is a teeter-totter. A second-class lever is when the load is located between the applied force and the fulcrum. An example of the second-class lever would be a wheelbarrow. A third-class lever is a lever when the applied force is located in between the fulcrum and the load. An example of the third-class lever is the elbow joint of the body. In a lever, the mechanical advantage of it is the amount of force that each machine must have in order to work.